Okay.
for like cubics and
Go ahead and give me the transformed formula, and we'll figure out how it was transformed.
so g of x equals parentheses x minus 3 and parentheses cubed minus 2. Or not cubed,
Squared?
fourth.
To the fourth.
To the fourth. Yeah.
Okay. It doesn't matter, as we're going to see here. What is the parent function?
X to the fourth.
What translations and shifts are going on with g of x?
To the right 3 and then down 2.
Good. What else you got?
So,
How about this one here? What's the parent function?
e to x.
Which looks
Power.
like e to the x power. Looks like that. Well, let me draw it a little bit better. It doesn't touch the x-axis. It's a typical exponential function. So what is happening here?
They're both negative.
Okay, what does that mean?
Is it just upside down?
Yeah, that's not bad. Let's take them one at a time. What would this be?
It would just be
Reflected
flip.
about which axis?
The x.
Okay, so if our parent function looks like that, minus e to the x would look like this. How about if instead of minus e to the x, I just said e to the minus x? What does that look like all by itself?
Would it be flipped over the y-axis?
Correct. In other words, this represents g of minus x. Whenever you have a g of minus x, that is a reflection over the y-axis. So it would look like that. And if you have both of them going on, then you do both. You reflect over the y and then reflect again over the x. So this would be the final, that would be negative e to the negative x. And that's about as hard as they're going to get.
Alright.
With relative to what you're doing now. In other words, the ones you were going to give me, if this was on there, it would be towards the end.
Yeah, no.
These are the tougher ones, where e is involved, or exponentials are involved. What other ones do you have?
So 3x to the fourth plus 2.
Okay, what's going on here?
Would it be a
Parent function
vertical
is x to
string?
the fourth.
Yeah.
So what's the effect of the 3?
Would that be a vertical shrink?
Stretch.
Stretch?
If, and you know what, I made a mistake calling these y, because if ever there was a place where you want to use the f of x terminology, it's here. And it's because I can look at this and see that, let me make that g, that g of x is 3 times f of x plus 2, right?
Yeah.
Well, if you have a multiplier of your function and it's greater than 1, it's a stretch. If it's between 0 and 1, it is a shrink. Okay? Now, to be straight, if I had f of 3x, that would be 3x to the 4th power. What is the consequence of that 3 when it's inside the function instead of multiplying?
I'm not sure.
It is a horizontal shrink. So horizontal and vertical are the opposite, meaning that when you have a multiplier of the function, it's a vertical stretch. If that number is greater than 1, it's a vertical shrink if it's between 0 and 1. But if you have a multiplier inside the function, it is a horizontal shrink if this number is greater than 1. And if this number is 0 to 1, it becomes a horizontal stretch. In other words, if I have a function f of x equals x squared, looks like that. If I have g of x equals 2x squared, well, the 2 is in front, which means g of x is 2 times f of x. Act as a vertical stretch factor. There's g of x.
Right.
Now, if I have h of x is equal to the quantity 2x squared, that means h of x is really equal to f of 2x, right?
Yeah.
Well, I said that acts as a horizontal shrink factor, and it does. There is the quantity 2x squared, which would be, notice, the same as 4x squared. So this horizontal shrink in this direction is the same as a vertical stretch. And that's why these two numbers tend to go opposite of one another. In other words, this acts as a vertical stretch, this acts as a horizontal shrink, because they both work in the same direction. Horizontal shrinks do the same thing. When you do a horizontal shrink on a function, you're pushing from both sides. In other words, you push in on that and on that to make it look like this. That is a horizontal shrink.
Yeah.
All right. That's about the only tough part. What other ones you have?
I just have a volume question.
Okay.
So the question is, the volume V in cubic inches of a rectangular box is given by V equals 2x cubed plus 9.
Okay.
And the first question of it is the function w of x equals v parentheses x over 12 gives the volume in cubic feet of the box when x measures in inches. Write the rule for w, then find and interpret w parentheses equals 6.
Okay, did I write everything correct? Is v equal to 2x cubed plus 9, like that?
Yeah.
And w of x is equal to v of x over 12.
Yeah.
Okay. Well, let's figure out what v of x over 12 is.
Alright.
How are we going to
So,
do that? How do you evaluate v of x over 12 if this is v of x?
so do you just put 2x to the third?
Substitute whatever is in the parentheses for wherever you find x. So it would be 2 times x over 12 to the third plus 9.
Alright.
So that's w of x. And of course that is 2x to the third over 12 times 12 times 12 plus 9. Well, we can take out one of those 12s and replace it by a 6. So now we have x cubed over 144 times 6. 864 plus 9. So there is the function w of x. And they wanted w of what?
6.
W of 6. Well, that's going to be 6 times 6 times 6 over 6 times 112 times 12, right? In other words, I'm backing up there. I got 864 by multiplying 6 times 12 times 12. I'm putting it back in factored form because it's easier to do the math here. I can cancel that 6 with that, cancel one of those with that. So now I have 6 over 24, it's 1/4. So w of 6 would be 1/4 plus 9.
Alright.
9 and a
That makes
4.
sense.
9 and a 4, yeah.
That makes sense.
So translations, let me make some up for you.
Alright.
This is what f of x equals log x looks like.
Alright.
What does g of x equals log of x plus 3 look like?
It would be left 3.
Okay. This first one has a vertical asymptote going through the y-axis. In other words, this function, as x gets closer and closer to 0, the function gets closer and closer to the y-axis. It gets closer and closer to negative infinity. So if I'm going to move this function over 3 to the left, the best way to do it is to redraw my vertical asymptote at minus 3 instead of x equals 0, and then draw my function being asymptotic to that, so my function looks like that now. And this is actually a very key point on all log functions. Where it crosses the x-axis, and that it always crosses it at 1, 0, regardless of the base. This can be base e, it can be base 10, it can be base 2, it can be base 17. Every one of them go through this point. So that's a very fundamental point on log graphs, that 1, 0. And so that point gets moved 3 spots left and is now minus 2, 0. So if you had to draw this graph, those are the two things you would want to focus on, is redrawing the vertical asymptote and redrawing the most important point on that function.
Alright.
And like I said, the only ones that are really hard is when you're dealing with that as a standard function, as a parent function. So what is minus f of x equal to?
Would just be minus e to x.
What is f of minus x equal to?
E to the minus x.
What is 3 times f of x equal to?
3e to x.
What is f of 2x equal to?
Would be e to 2x.
What is f of x plus 1 equal to?
E to x plus 1.
And finally, the last thing that we can do is what is f of x plus 7 equal to?
Would be e to x plus 7.
Like that. And there are your 6 translations. We have 2 reflections. We have a vertical stretch or shift. We have a horizontal stretch or shift. We have a horizontal translation. Excuse me, I didn't mean stretch or shift, I meant stretch or shrink.
All right.
This one is a horizontal shift, the f of x plus 1. That is a shift of 1 to the left, whereas this is a vertical shift. So it makes it tough to talk about all these things because you have stretches, shrinks, and shifts. And they all start with SH or SCH or something, I don't know. But that definitely is a difficulty when dealing with translations, is the fact that the words all sound so similar. Stretch, shrink, and shift. And they all mean something different.
All right.
All right. What else you got, Mitch? Anything?
No. Our homework tonight was really easy.
Okay. Did they delay schools today, or did they start on time?
We had our late start, our normal late start, so we didn't start till 8 o'clock.
Okay.
So kind of, but we always have it.
I wasn't sure if it was going to affect my tutoring today because I was thinking that if you start late, do they go late? In other words, if they delay the start of school by an hour, do they go over by an hour?
I don't think so.
No, you just missed your first hour's class, huh?
Or they shorten the period.
Oh, they shorten everything. Okay. Yeah. I wasn't sure whether it would matter for my students, whether they'd be out of school at the regular time today or not. Because I noticed that most of the schools were delaying the start by a little bit.
Yeah, we just had and then they weren't taking attendance till the end of class because people were just walking in because they were getting stuck and stuff.
Were they? Yeah.
Yeah.
Yeah, it's pretty nasty out there. I'm not looking forward to going out here in 10 minutes. Well, Mitch, if you don't have anything else, I'll let you go.
All right.
Let's see. We're on for Wednesday at same time, 4. Not same time, at 4 o'clock on Wednesday. Yeah, our Wednesday and Saturday time is 4 o'clock, and our Monday time will be at 6.
Yeah.
All right. Talk to you Wednesday.
All right.
Bye-bye.